All right, so if you ever hear me speak about anything, so I talk about other things besides numeracy, but my theme in life is mathematics is figure out. And so we want to differentiate between two kinds of knowledge that are very pertinent to what we do. We want to talk about things that must be memorized, that's social knowledge. Things that are handed down from other people, we can't figure them out from the inside out. We can't mess with the relationships and come to some conclusion. Somebody's got to tell us in order for that to make sense. But then there's that other side of stuff that if we have some basis to work from, then we can figure through. We can mess with stuff to the point where we can come to some conclusions on our own, that we can own that knowledge so we can use it for other things, that logical, mathematical knowledge. Let's parse that out just a little bit more today. So as we do that, there we go. So to memorize, do we memorize coins? Let's parse out some social knowledge versus logical, mathematical knowledge. So do you think our coinage system in the United States is real logical, that it makes sense, and that if we just give kids some coins and we let them play around with them for a while, that they will figure out that the really big nickel is worth less than the small dime? Does that make sense to anyone? Who came up with our coinage system? What was that? I mean, it kind of makes sense that the penny, there's 5 of those, they make that slightly big silver dime or nickel. That makes sense. But then 2 of those is one of these small dimes, and then 10 of the big pennies is worth more than that small. It doesn't make any sense. That is a social construct. Somebody said, hey, let's make our coinage system make absolutely no sense whatsoever. As far as the size goes, right? That doesn't make any sense. And so that is difficult for kids. Now, that's not the only reason that our coinage system is difficult for kids. It also involves unitizing. Hey, pre-K2 folks, do you know what unitizing means, right? Yeah, have you guys talked a little bit about unitizing? If you haven't talked about it yet, bug those guys. I need to talk more about unitizing. So unitizing is one of the reasons that our coinage system is hard. That needs to be constructed. That big idea that multiple things can be represented by one whole, multiple pennies can be represented by one nickel. But the social part of that is that the dime is smaller than the nickel, is smaller than the pennies, but yet it represents more of them. And another social part of that is that we have these certain colors and shapes and designs that represent an amount at all. The fact that the penny represents a penny and that the quarter represents a quarter, couldn't we have switched those around? I mean, we could have. Why is it that the copper is the penny? And then you might go into, well, because it's cheaper and all sorts of... By the way, did you know that pennies are only like 2% copper these days? Maybe it's 10%. But anyway, they're not very copper anymore. So the fact that we've decided to make them that way, that's social. So we have to tell kids that. They can't sit and figure that out. Now, once they know what the amounts are, then they can sit and construct this unitizing idea of what represents what. So we have to kind of sort of parse out which part of that coinage do we need to tell kids, and which part do we want to give them experience so they can construct the understanding of the relationships. Let's do another one. How about multiplication facts? So everybody thinking for a second. Is that social knowledge? Logical mathematical knowledge? Part of it, we sort of parsed out with the coins that part of it was and part of it wasn't. So what about multiplication facts? Everybody think about that for a second. When the person next to you is ready, will you turn and have a brief conversation about, do you think we need to memorize multiplication facts, or is that stuff that we can construct from the inside out using relationships? Where could I go? All right. So thank you for having that conversation, even though most of it was about math. Thank you. So I'd love to hear from somebody your thoughts. Multiplication facts, to memorize or not? To construct or to memorize? What do you think? What did you think before you came here this week? Memorize. In fact, I threw out to my, it was one of those social medias, Twitter, Facebook. I'm not very good at those. I'm trying. I am making the attempt to be social media adept. I threw out a question to the world, and I said, hey, what do you have to memorize in mathematics? Hey, if you are that social media person, I would love it if you got on my Facebook page and liked it, and then you can follow that conversation. I'm going to ask it again really soon, and I'm going to say, what are the things in mathematics that have to be memorized? I'll tell you, part of this keynote came from comments you guys made in our sessions yesterday and the day before. You're like, okay, so there's this bit about what needs to be memorized and not, and we're learning that there's far less that needs to be memorized than we ever thought. So what is that set, that small set of things that has to be memorized? You guys asked my presenters that. And so they were like, Pam, we probably ought to talk about that score. What are the things? And so I said, you guys tell me. We came up with this great list of things that need to be memorized. So we are throwing it out to you guys. What needs to be memorized? What is that set of stuff social knowledge that we have to tell kids. And then we want to help them memorize it with rhymes, mnemonics, raps, or whatever. And so that's what we're doing today. Before you came, multiplication facts, you got to memorize those, right? Think about flashcards, we got to memorize them. Can you think of an example? Somebody justify why we don't need to rote memorize. Do I want kids to know their facts? Let's be clear. Yeah. Absolutely. I want kids to more than know their facts. I want them to have their facts and relationships that they can use for more than just the single-digit facts. Anybody say any more about that? I'd love to hear your thoughts. I know it's a big group. Did I just say too much, probably? Do you know what I'm asking? Multiplication facts. To memorize, not to memorize, and why?
I think you need to memorize them so that you're quick. You need to memorize them so that you're quick. And it leads to other things that you can build on from that, knowing that knowledge. But I also think that when you start multiplication, that you need to show them, okay, 3 sets of 5 is the same as 3 times 5, so that they can figure that out. So there's a little bit of memorizing, and there's a lot of instructing.
What do you think about that? Comments? Talk back to your peer group. I'd like to define memorize. When I put memorize up here, I mean rote memorize. Go ahead and finish the sentence you're on. All right, group. When I put the word memorize up here, I mean rote memorize. I don't mean know them and have them at my fingertips and so that I can use them for other things, which is exactly what you said. I need to have them because I need to build other stuff on those facts. Totally agree I need to have them. My beef is how I get them. Do I get them through relationships or do I get them through 7 times 8 like the garden gate is made of sticks, so it's 56. That was on the wall of my 3rd grade kid's teacher. And I went, ah! Because what if I just sort of tweaked that a little bit and went 6 times 8 like the garden gate is made of sticks, so it's 50. No, whoops. Is it 7 times 8 or 6 times 8? That's an example of rote memory. So when I say to memorize, I mean flat, cold, rote memory without relationships. So I think what I heard you saying is, kids have got to have, you said it very well, that 5 groups of 8 is 5 times 8, and I didn't know the meaning, and I've got to have those multiplication facts at my fingertips to build other concepts on them. But how do I get them at my fingertips is my beef. I want to get them through relationships. I want kids to construct those multiplication facts so that they really own them, so that my kid doesn't just memorize 5 times 9. Do you remember yesterday? He doesn't just memorize 5 times 9 by 10 times 9 is 90. Half of that must be 5 times 9. Half of 90 is 45. But he can do 5 times 23. Really, he could do 5 times, pick an ugly number. Somebody, pick an ugly number. What was it? 97. 97. Ooh, that's ugly. I agree. So, what would 5 times 97 be? You really picked an ugly one. Yeah. What's 10 times 97? This would actually be really nice if I could write right now, so I'm gonna see if I can do this. Okay, that's interesting. Give me just a second. I just need to do one quick thing. So you just said 97. Let's work for just a second with 97. What is, yeah, thanks everybody. What is half of 97? Do you know? What's half of 97? Help me work on that. Do you know half of 90? What's half of 90? 45. What's half of 7? 3.5. So what is half of 97? 48.5. Does that help you think about, so remember yesterday my kid's strategy was 10 times 97. He wants to get 5 times 97, right? So he said, if I know 10 times 97, what's that? 970. So then can I find half of that to get 5 times 97? So what's half of 970? Is that 485? So that's an example of more than knowing my facts. I so know the relationships about 5s being related, and for some of you, we're like, wow, it's okay, you picked an ugly one, nice ugly, so I wanted to sort of help with, maybe we could have just done half of 970, that might have been easier than half of 97. But the point is, I can use that to figure out 5 times anything, so I want to more than know my facts. So if we go back to that presentation, maybe I should have up here, to rote memorize, cold, with no relationships, where I'm just using rhymes or facts because there's no relationships to help me have that feel in there. So do I want to have them at my fingertips? Absolutely. But I want more than that. And I can say that from experience. Remember, I was the memorizer. I was the one that knew my multiplication facts down cold. I won around the world. I was good at that. I liked it. But I had no relationships. When my kids said, you don't have to know your 5s if you know your 10s, I was like, really? I could not even think about how multiplying times 5 was related to multiplying times 10 because I had no relationships. I can have relationships, and so can all of us. And so we're going to build that, and we have been building that in you guys all week. Let's do another one. What about the orientation of the number line? If I were to look at a number line like this, does it go small to big or small to big? Which way does that go? Small to big. What is that like? Reading, right? We read left to right, so it's consistent. And who came up with that? Not the reading part, but the number line part. Could it have gone this way? Yeah. Who came? Yeah, that look, she's like, I don't think so. That's weird. That would look strange. Well, I'll just tell you, in my middle school group, we have a couple teachers that have number lines going all sorts of ways. Yeah, they're laughing right now because it's been kind of a joke up there. We had number lines going this way, that way. We had numbers out of order on the number line. Because we have a lot of math teachers that learn mathematics as memorization. They're like me. And so when they have to start thinking about relationships, they have to construct those relationships. So the orientation of the number line. Do I want to memorize that? Yeah, actually, because somebody just decided that it was going to be that way. Then I want to construct the relationships on that number line. All right, what about another one? There we go. How about names of numbers? Do you think if you sat a kid down with a bunch of numbers, they could just decide that 12 is 12? No. Who came up with the word 12? What is that? What should the word 12 be? 10. Oh, pre-K2, you've done well. Hey, pre-K2, say that a little louder. What should the name of 12 be? 10. Hey, for the rest of you, 3-5, I'm assuming you haven't talked about that, right? 3-5, not so much? Okay, so neither has my group. Somebody pre-K2, why? Why should 12 be called 10-2?
It's because all the other digits, like 25 is the 2 and then the 5. In other countries, that's how they do theirs.
Yeah, in many foreign languages. So I'd love to tell you a quick story. I teach at UT, where I teach math methods. So I have this wonderful class and people that are about to be teachers. There you go. Nice. All right. And no A&M hissing. That was interesting. So as I'm teaching, I'm telling my students this very thing. I'm like, hey, did you know in many foreign languages, the word for 11 is 10-1, the word for 12 is 10-2, the word for 13 is 10-3, the word for, and students often go, that's dumb. And I'm like, okay, 14, like 16, 17. I mean, the numbers in the name. Okay, not 15, it should be 15, right? And they're like, 15, that's dumb. 16, 17, 15 is not dumb, it should be that way. And I have this wonderful Oriental student sitting in the room that she goes, oh my gosh, you're right. She had grown up speaking, I don't remember which Oriental language, but she had grown up speaking that language. She goes, holy cow, I never thought about that. I never thought about the fact that 20 is 210, and 21 is 210-1, and 25 is 210-5. It is! And she told us the words and wrote them on the board, and it was great. So anyway, so it was just kind of a funny story. I was like, yeah, okay, now maybe they'll believe me about other stuff. So names of numbers. Do I want to rote memorize that, or do I want to construct it? How do you construct that? It doesn't make any sense. Can't construct that. I have to tell kids the names of numbers. But boy, howdy that I can construct the relationships among those numbers. How about if I were to ask you when to use a particular strategy? You have all learned some strategies in the last few days, and so you might be saying to yourself, how do I know when to do that one? How do I know when to do that one? Now, is that something we should be telling you? We haven't been very clear. I know. We should get better at that, right? We should say to you, okay, everybody ready? This is when you should use that strategy.
No.
Big smile right here. Why not? You're shaking your head.
Because not everybody thinks the same way.
Not everybody thinks the same way. Any other ideas? You like the face?
And they won't have to think.
There's more than one way? Well, we're definitely showing you more than one way. We've got different strategies. What would you say?
You want them to be able to think about each strategy and pick the one that's most efficient.
Ooh. We want to be able to go through several strategies. I have several in my mind. I got these 3 main strategies. Which of them is going to be the most efficient for these numbers? Can I just tell you every number? All right, for these numbers, we'll make a big list of all the numbers in the world. And for these numbers, this one will work the best. We can start to categorize which numbers will work the best, but that's something we need to construct. That's something that you guys need to say, I'm noticing that every time there's a 9 involved, I kind of want to do this. But every time there's a 1 involved, I don't want to do that. And when is that true? When are the kinds of things that you want to do when there's different numbers involved? That's something that has to be constructed. We're almost done with this. How about the look of numbers? Like, why does a 3 look like that? Because that's what a 3 is, right? Who came up with that? A 4, a 5. Social knowledge. Obviously, social knowledge. We've got to tell kids this is what numbers look like, numerals. This is what numerals look like. And then, boy, yes, practice letting those kids develop that dexterity and that fine motor skill to write those guys down. Social. So you can do lots of things to help kids memorize that, rote memorize that. It's not something that they can sit down and figure out. Hey, if 1 looks like this, and 2 looks like this, and 3 looks like that, you just sit right there and you just work with relationships and tell me what 4 looks like. See how that doesn't work? I gotta tell you what 4 looks like. There are times in education when you can tell, but boy, in mathematics, those are very few. I'm actually bringing up the few times that we need to tell. How about measurement names? If I sit you in a room with the word pint and the word quart and the word cup and the word teaspoon and the word... Can you figure out how those are? Just the words, right? I'm not giving you, some of you are like, well, yeah, if you put me in the room with all those measurements and I can start dumping them in. What is that? If you start dumping them in to see how much one is worth, that's experience, that's construction. I love that you're thinking that way. But to put the name to this size of thing, it's totally social. That we have to tell because some random person somewhere came up with the fact that we should call that a quart. Quart. We could have called it a pound. Whatever. Who knows? That's social knowledge. We need to help kids know that kind of stuff. We have to tell them.